Moving the most valuable piece of industrial equipment on Earth requires 7 Boeing 747s, a military-grade security detail, and intense logistical precision. The cargo inside is the ASML Extreme Ultraviolet Lithography machine. It costs $380 million. It is the only tool capable of printing the microscopic circuits inside your phone, your car, and every AI supercomputer. The public narrative of the semiconductor war is centered on geography. Whichever nation physically captures the factories holding these machines controls the future. But ASML and the foundries built a contingency plan into the hardware. These machines are wired with a remote kill switch. Without a digital handshake from the manufacturer, they can be deactivated from 6,000 miles away. A military invasion wouldn't capture a functioning factory. It would trigger a $100 billion suicide pill, turning the most advanced facility on the planet into a tomb of inert metal. We often imagine this industry as an immovable fortress, a physical empire centered around the massive foundries in Taiwan. Those buildings are the final stage of a globe-spanning web, a network of hyper-specific resources that cannot be stockpiled or easily replaced. This is a daily struggle to keep a complex machine from tearing itself apart. The modern world runs on a supply web that operates on the edge of structural failure. A multi-billion-dollar cleanroom cannot function without a steady flow of specialized raw materials. In March of 2026, while the world watched political maneuvers, the tech industry faced a crisis caused by a shortage of ultra-pure helium. This map shows the global flow of that gas. A bottleneck in Qatar cut off 30% of the world's ultra-pure helium. Without it, manufacturing advanced processors is physically impossible, halting supply lines to major hubs in Korea and Taiwan completely.
A disruption in an entirely different part of the world proved that a gas shortage can shut down global tech production more effectively than a military blockade. The bottlenecks go much deeper than logistics. If we zoom all the way down to the surface of the silicon wafer, we hit the point where traditional computing logic breaks down. This diagram illustrates the 1 nanometer wall, where electrons pass straight through solid matter, a phenomenon known as quantum tunneling. In May 2026, researchers at UC Berkeley published a potential exit to this physical dead end. They discovered that by transforming titanium dioxide into a stable ferroelectric material at thicknesses under 3 nanometers, they could force the atomic structure to realign, creating a barrier that stops the tunneling effect. The race to build the next generation of computing relies on outmaneuvering the laws of quantum mechanics. Even if physics allows us to keep shrinking chips, the geographic concentration of where they are made has created a different kind of vulnerability. This blueprint illustrates a hardware Trojan, a malicious modification made to a chip's microscopic architecture during manufacturing. Because this sabotage is baked directly into the physical structure, software cannot detect it. Watch a standard security scan sweep over the compromised pathways and report 0 threats. When almost all of the world's advanced manufacturing is isolated to a handful of facilities, verifying that every piece of silicon is clean becomes impossible. The backdoor access to critical infrastructure might be pre-installed inside the hardware of a device before it ever leaves the cleanroom. When you look at the chemical bottlenecks, the physical limits, and the hardware vulnerabilities, the idea of a single nation achieving semiconductor dominance becomes impossible. Western economies rely on rival nations to mass-produce the legacy chips that keep power grids running, hospital machines operating, and cars rolling off assembly lines. Conversely, those manufacturing hubs cannot design or print an advanced wafer without Western-controlled software and European lithography machines. If any player tries to lock down the supply chain, they sever the exact inputs they need to survive. The system paralyzes everyone involved. We don't have a victor, and we don't have a monopoly.